it's time to do it. All right, so the section that we're taking a look at is called, get myself all discombobulated, Explained and Unexplained Variation and the Least Squares Regression Line. Your explained variation is basically when you have sets of dots or sets of points on an x and y axis, the line that you try and draw through it is what's the explained variability. And we're trying to look at explained versus unexplained. And so the first thing that we're going to do is we're going to take a look at, before we look at the problem, let's look at this output. And so quickly looking at the output, the x and y over here is your collected data. Okay. So the x and y on the far left, it's just somebody went out and collected a bunch of variables on x, and then they also collected a bunch of variables on y. If you look over here, I guess I got to get rid of this too. No, I can leave you red. Sorry, I'm talking to myself. If you look over here, if people truly believed that the line is working, and well, so let's talk about explained variation. Sorry, I don't want to give you any more of a headache than you already have. So there was a blue dot here, and then we have a line going through them. All right, so if we look at this data here, we have 5 points, and we're trying to fit the best possible line through them to try and explain the variability in our y. And so the blue line does a pretty good job because it goes through and it touches or is close to most of the points. So that's called explained variation. And explained variation comes from 3 parts. Well, first of all, there's 3 things. There's y hat, which is what we get when we plug an x value in the magic regression equation. There's y bar, which is the average of all the y variables. And then there's y, what really happened. And so when we take our y hat, what we predicted to happen, minus our y bar, this is our sum of squares regression. When we take our y minus y bar, that is our sum of squares total. And when we take our y minus our y hat, that's our sum of squares error. And so in this case, our total sum of squares is here. Our sum of squares, the amount of variability that's being explained by that regression line, and the amount of variability that's not being explained. So now let's take a look at the question. The question says, the variation of the sample y that is not explained by the estimation of the line. So what's not being explained? The error is not being explained. So the variability that's not being explained is the error, and the error is always going to be this y minus y hat column. So 741 would be our error. Okay. Then they talk about the R squared. R squared is probably one of the more vital pieces of statistical information you want to be able to find. R squared is the proportion. A proportion is just part over whole. It's the proportion of the total variation in the sample that is explained by the regression equation. So it's saying what proportion is my explained over my total. The explained is 3881. The total is 4636. And the unexplained is at 741. So since R squared is my explained, we're going to take 3881.8821. And we're going to divide it by the total of 4636.9920. And our R squared is 0.837155. And to make my life easier, usually put as many decimal places. Actually, you can copy it. So you can go in the Alex calculator and copy it, and then come here and paste it, and then you don't even have to worry about decimal places. Right. The least squares regression line given above is said to be a line that fits sample data. That's the whole point. The term best fit is used because the line has the equation that minimizes the error. I want to minimize the mistakes. So I want to minimize the error, the sum of squares error. And like we said, our error is this 741 here. And then finally, for the data point 282.2 and 258.5. All right, so they gave you an X and a Y, and they want to know the residual. So 282, 58. So 282 is over here, and 258. So this is the point that I had to draw back in because I'm a terrible drawer. But let's talk about it for a second. Let's talk about drawing. So we're talking about this point right here. Okay. And when we're talking about this point right here, we want to know, what is my residual? How far off is it from the line? So what is the distance between the point and the line that it's going to? And so what I really want to know is, how much distance is there here? Okay, what distance is that? To get it, all I'm going to do is take the x variable, 282.8, and plug it into the equation. And I want to find out what is the actual value. We already know is going to be 258.5. What was the predicted value? So we know the actual value, y equals actual, when, sorry, I should say y. When x equals 282, then y equals 258.5. But what would we predict it to be? So then we're going to take our equation, and our equation is y is equal to negative 9.00 plus 1.02x, but we're going to plug the x value in. So the x value is 82.2. So when I want to predict it, to get this y hat value here, all we're going to do is we're going to plug in the known value into the equation. And so if I do that, if I take clear negative 9 plus 1.02 times 282.2. So hopefully, please excuse my dear Aunt Sally. Nope, that didn't do it. This whole thing should be negative 9. So negative 9 plus 1.02 times that should give me 278.884. And so my line would predict it to be 278.8.4. My residual says, okay, here's what it is, and here's my line. So how far off am I? So to get my residual, I take what actually happened minus what I would have predicted to happen. So what actually happened was 258.5 minus my prediction of 278.884. And so it's telling me I'm below the line by 20.334. So your residual is your actual minus your predicted. And that's it. So let's take a look at how we did. Maybe try one more. One of them it didn't like. What did you not like, Alex? Oh, because it was negative. We were off, but remember, it's below the line. All right, let's try one more now that we've gone through all that fun stuff. Let's do one more. All right, so again, we have this crazy picture. Notice they keep flipping these guys around. So you're going to want to know which one's which. So sum of squares totals, y minus y hat bar. So there's our sum of squares total. Your sum of squares regression is y hat. Oh, no. Okay, they kept them the same this time. All right, we're good. So for the data point, they want to know the value 147, 105. So 147, 105, that's right here. So we want to know how far off is it than what we would have predicted it to be. So to find the residual, the first thing we do is we take the x value and we put it into the equation. So we say, okay, the equation is 270.18 minus 1.08 times the x value in this is 147.7. And we get 110.664. So that's what we predict it to be. But it's actually 105.06. So we take the actual 105.6 minus the predicted will give us the residual of negative 5.064. So that's probably one of the harder sections. The other stuff's a little easier. The least squares regression line given is said to be the line of best fit. The term best fit is used because we want to minimize our error. Our error in this case, y minus y half, our error, we want to minimize our error. And to minimize our error, that's 325.78. The variation in the sample y values that is explained by the relationship between x and y. The variation that is explained. The explained portion is y hat minus y bar. It's your sum of squares regression. That's the explained part. The error is unexplained part, and together they make the total. So the explained part is regression, and the amount of regression is 1238. The proportion of the total variation of the sample y, that's explained. That's also called R squared. It's your explained variability. There is variability. How much of it is explained? Explained comes from your regression. So we're going to take our regression number, 1238.5719, and we're going to divide it by our total, 1553.18, and get our R squared of 0.79744. Actually, I'm going to just copy and paste it. Okay. Do you have any questions? Okay, so let me end the recording. There are no tests in the program. You're just moving